Hello everyone. Uh, Thank you for joining today. We are Asian Cloud Community. We are a part of Microsoft Technical Community in Singapore. Asian Cloud Community. There are many other communities that comes under Asian Cloud Community, not only in Singapore. There are communities from other regions as well, Malaysia, Singapore, and Sri Lanka, Bangladesh, and Nepal. So you can see all these countries comes under Asian Cloud Community, and Azure Singapore community is a part of Asian Cloud community. So if you want to join our Facebook group, so you can join, you can connect with us on MS Technical Communities in SG. We also have our meetup group.com. So all our latest meetups announcements are available on meetupgroup.com, and it is also posted on Facebook. So if you are following us on Facebook or meetupgroup.com, you will get a latest update. Asian Cloud Community also having a website. So that asiancloudcommunity.com, so you can follow there as well. Means all our communities links are available there, and if you like to present or organize a session, you can contact in any of the organizer, either in Microsoft means Azure community or .NET community or ML community. There are many other communities in MS Technical communities, so we can help you to connect with other communities, and if you want to speak or organize, you are welcome. In past last 2 years, we have done very good sessions on Azure. So there are many different topics on Kubernetes, containers, and we also have done some series, Azure DevOps series in past December, and we have also done API building series. So if you are interested in any of the sessions, so you can subscribe our YouTube channel. That is available on our YouTube channel. So you can just go and Azure Singapore sessions. All the playlist you can see our previous sessions are available there. In today's sessions, Nilesh is going to speak on topic of improved monitoring and observability of our Kubernetes with OSS tool. Nilesh is a Microsoft MVP, and he's a big data and cloud solution architect in Singapore. He is also one of the organizer for Azure Singapore community, and he have really good experience in different technologies, and especially in Kubernetes and containers. Means like he have done a lot of really good sessions on in Singapore community and many other communities, in India community of MS Refactor. So yeah, if you are really interested in containers and Kubernetes, I think you can follow his blog, and he's quite active on Twitter as well. So yeah, you can see. About related to today's sessions, Nilesh and few other speakers have done some sessions in past. If you are interested in doing a Kubernetes certification, there is a session done by Fajal, and if you are following Nilesh, he's also have done some really good videos on how you can certify, because he's also certified in Kubernetes developer and administrator. So he have really done good videos on YouTube. You can follow me later on. I will post the link of the YouTube channel of Nilesh. He have so you can follow there. It's really nice videos there available. And if we have done a few sessions on Kubernetes experience with VS Code, so if you are familiar with if you want to familiar with the Kubernetes with VS Code extension, so you can see this session, and yeah. And we have also done some chart sessions in previous past. So if you are interested, you can see our YouTube channel. So all the session recordings are available there. This is our YouTube channel. So if you haven't subscribed yet, please do. This is a MVP United Most Available Professional. You can search, or you can just scan the QR code and go and subscribe there. Before hand over to Nilesh, there are a few reminders. Please keep yourself on mute during the session. This session is being recorded, and if you like the session, please help to spread the words on social media. So yeah, I think Nilesh sir, over to you.
Thanks, Asif. Thanks for the introduction. Let me share my screen, and please let me know once you are able to see my screen.
Yeah.
you able to see the slide?
Yes, I can see.
Okay. Looks like we are having some issue with the YouTube stream. I'm not able to see the streaming happening on YouTube. So maybe you can have a quick look while we get started. Okay. So as Asif said, today we are going to talk about how to improve the monitoring and observability for Kubernetes using open source tools. My name is Nilesh. I put the social media handles for my Twitter, LinkedIn, and GitHub account as well, and my website. If you have visited this Azure Singapore community before, you might have attended some of my sessions. And as Asif was mentioning earlier, I'm certified in the certified Kubernetes administrator as well as CKAD, and I did some videos about how to pass these certifications, some tips, some tricks, how to prepare for them, and shared my experiences. So feel free to have a look at them in case you are preparing for these certification exams. And if you have any doubts, feel free to reach out to me. So for today's session, there are some prerequisites, I would say, because we are talking about Kubernetes, and I would expect some sort of basic understanding from the attendees to know about Docker. So Docker is a self-contained application. It helps us to containerize the application or package the application with all its dependencies. Once we have the Docker, what is called as an image, then we can deploy it onto cluster, which is nowadays mostly Kubernetes cluster. And Kubernetes provides various services or various features, like it obviously orchestrates the containers. It also has self-healing. So if something goes wrong with, let's say, whatever workload you're running in the cluster, Kubernetes can automatically take some actions to correct those pods which are not working as per the expectation. There is also things like service discovery, and it can support very different kinds of scaling, like automatic scaling based on different metrics and things like that. So I've done a couple of sessions on KEDA as well. If you want to learn about how to do event-driven scaling, you can look at these past sessions which are available on our community YouTube channel. And then we also expect a basic understanding of cloud native applications. So these are scalable applications which can work in any environment. It can be a public cloud or private cloud, or it can be a hybrid cloud where you run partially some workloads in public cloud like AWS, Azure, or Google Cloud. And then some of the workload can be running in your own data centers. These applications, these are exemplified by containers. So majority of the cloud native applications nowadays, at least the new ones, we containerize them and we make use of container technologies. There is also service meshes, which is gaining quite a lot of traction. So when you want to have service to service communication within your microservices, then you use type of communication mechanism which is called as service mesh, and Istio is an example of this. There is also immutable infrastructure. So whatever we do with the code in terms of organizing our code by means of putting it in source control and using like Git repositories or some other form of code repositories, this can be done for the infrastructure as well. And that is where things like Terraform or infrastructure as code is quite popular nowadays. And these applications or the cloud native things, they also work with declarative APIs. So instead of having tight coupling, they use APIs to define the contracts and then work with the APIs in a loosely coupled manner. They're also resilient and observable. In the past, we used to build applications which are like 100% available, but now as we move from managing our own data centers to deploying our workloads on public cloud, there could be possibilities that you have issues with the cloud provider. Let's say one particular region goes down. So in such scenarios, you need to build these applications with high availability in mind and resiliency. And that is where we have the resiliency coming in picture. And we also need to make them observable. So if something goes wrong, they should be easier to heal. And all this means that there should be a lot of automation. Our control on the services that we deploy on, let's say, Azure or AWS in public cloud, as we move from infrastructure as a service to platform as a service, and then other kinds of services like database as a service or Kubernetes as a service, for example, or serverless for that matter, our control on the underlying infrastructure is less. We don't have so much control as to how we can manage the underlying infra. Sometimes we don't even know where our application is running. The cloud provider would just ask us questions like, what is the framework that you're going to use, or what is your technology stack? It could be a .NET or Java. And then if it is interfacing with database, based on these initial set of questions, it can go ahead and deploy it in its own platform as a service. And we would get just the right kind of access or role-based access to manage the application, but not to manage the infrastructure. So these are the things which we need to understand in terms of how cloud native applications works. So in this topic, as we said, we'll be focusing on monitoring and observability for Kubernetes. So most of the things that I talk will be focused from here on the Kubernetes part. I use this iceberg as an example to explain to people how the complexity increases as we start containerizing applications. So if you look at this picture, the top two layers is like most easiest one, I would say. When you start building applications, when you start containerizing, you will find a lot of information on the internet as well, where people talk about how do you use Docker to containerize, how do you use things like secrets, config maps, how do you expose services in Kubernetes. That's easy to get started. As you start moving into enterprise kind of scenario where you need high availability, where you need, let's say, storage capabilities, where you need to persist data, which is maybe, let's say, Postgres database, or you're using some open source database and you're running that database engine on Kubernetes, then things start to get complicated. Then when you add things like the roles, when you add things like networking, all those things, as you go down this different layers, the complexity goes higher and higher. And that is where you will see that many people, they say it's easy to start with Kubernetes, but to manage it, it does become difficult. And more services you put on top of this, you need that special skills to manage these kind of environment. So this is where I find the Cloud Native Computing Foundation, or CNCF, guidance in terms of what projects are available to build cloud native applications, and what support they provide, or what guidance they provide from time to time. So if you look at this screenshot, or this particular infographics, it's called as the CNCF Cloud Trail, and it categorizes different projects which are part of the CNCF Foundation into 10 different categories, or 10 different segments, starting with containerization, CI/CD, orchestration, observability, and so on and so forth. And it tries to give a sort of guidance saying which are the projects which fall under each of these categories. And if you are interested in using these projects, in what kind of scenario you can use them. So when it comes to observability per se, as of this morning when I checked, there are about 73 projects which are currently under observability umbrella. And this again is available at landscape.cncf.io if you want to have a look. Within observability, this is categorized into monitoring, logging, tracing, and chaos engineering. And monitoring takes the majority of the space. Each of these projects, they go through different phases. In CNCF, so some of them are already edited. And if you are interested in picking one of these projects for your use case, you will find what is called as a technology radar, or the observability radar. The radar concept came from ThoughtWorks, and ThoughtWorks team, they were publishing the technology radar on a regular basis. So CNCF adopted a similar approach, and for different categories, observability is one of them. They have come up with a radar saying what are the different categories in which these projects fall. And this came back in September 2020. I'm still looking for the latest version or updated version, but it still gives us an idea in terms of what does CNCF recommend. So if you look at the circles or semicircles below, you have three categories: adopt, trial, and assess, where Elastic, for example, or Prometheus is recommended to adopt. So if you're starting a new project, you can straight away go ahead and adopt this. Things like Splunk, Sentry, Jaeger, for example, are in trial mode or were in trial mode in September 2020. And CNCF was also recommending that you could assess things like OpenTelemetry and TLE. So in this discussion or in this session, we are going to see how we can use some of these projects. Like Elastic, we'll be looking at Prometheus and Grafana, and Sentry as well. So because we are talking about observability, let's see what constitutes observability, or what are the main three pillars of observability. First one is logs. So logging is like very central to any application, and it is one of the oldest form of debugging. I think right from the early days of computer software, logs have been there. So it's basically a textual form of some sort of event which happens. Let's say typically when a process starts, you would put a log entry saying starting so and so process, when it finishes, and then you would try to find out the durations and things like that. That is the legacy way of handling logs and looking at performance. More recently, we have metrics, which are more like numeric figures and related to different aspects of the program or your infrastructure and things around software. So it makes more sense to look at metrics from a combined form instead of looking at just, let's say, single entry or single data point. We would look at metrics over a period of time. So usually we use metrics to see what is the average, let's say, response time over 5 minutes or 10 minutes, depending on the type of applications, or how much is the resource usage, for example, CPU or RAM. How much is it being used on an average within an hour or within a day, those kind of things. And then we have traces. So traces, it gives us like a context around how the request flows. Since we are talking about Kubernetes services, nowadays you have polyglot programming where within the same application, you might be using multiple data stores. So let's say you might be using a SQL database or relational database. You might be using a NoSQL database. For some caching purpose, you might be using messaging. And when a user makes a request, it can flow through various of these components. So traces or distributed tracing, it gives us an idea how the request originates and how it flows through various parts of the system. So let's focus our energy or discussion on centralized logging to start with and see what are the options available, or why do we need centralized logging in the first place. Since we're talking about containers, let's start about container-based workloads. So within container-based workloads, I would say there are two types, or I would categorize them into two different segments. One is application specific. If we look at Kubernetes, for example, the logs which are generated in Kubernetes, they are stored locally on the node for a very short duration of time. And if, let's say, for compliance reasons or for the long-term retention purposes, we need to store these logs beyond whatever is configured as the default time for the rotation of the logs, we might lose those logs which are stored on local disk of the Kubernetes nodes. The other one is, as I said, the Kubernetes has this capability of self-healing. So it might so happen that currently your workload, which is typically a pod, is running on, let's say, node 1, and your application restarts. Kubernetes might try to reschedule this pod, and it gets rescheduled on completely different node. So if you use the local storage of that particular node, you would lose the history of those logs. Same thing could be for auto scaling. So if we are automatically scaling, cloud is all about saving cost, right? So now we can scale our pods or our workloads based on how much demand is there. So it can so happen that on a minimal basis, we might be having, let's say, 5 replicas, and then it can scale from 5 to 50. And then when the load decreases, it might again scale back to 5 from 50 replicas. So in such cases, again, if we are using the local logs, we would lose them and we will not have the retention. If you look at the underlying Kubernetes infrastructure itself, typical example that comes to mind is when we upgrade the Kubernetes cluster. If we are using, let's say, managed services like Azure Kubernetes Service, if we upgrade the Kubernetes cluster, it doesn't upgrade the existing node. It adds a new node, and let's say current version of our Kubernetes cluster is 1.20, and we are upgrading to 1.21 or 1.23, whatever is the allowed upgrade path. So all the nodes which are currently running 1.20 version of Kubernetes, they will be there, but the way the upgrade would happen is the process would drain a particular node. It would not allow more scheduling to happen. And then it will add a new node with the upgraded version. And then this workload would be rescheduled to run on the new node. Similar thing can happen if we have enabled the cluster autoscaling. So Kubernetes or Azure Kubernetes Service, for example, allows us to configure the Kubernetes cluster to autoscale. So depending on the demand for resources, it can scale up and down. And as I just mentioned, if the underlying node gets replaced during the cluster upgrade, so we would lose the logs in such scenario. Same thing is in case of PaaS or serverless services. Since we don't have much control over the underlying infrastructure, we have to rely on the cloud provided services. Like in case of Microsoft Azure, it could be Log Monitor or Log Analytics, which stores the logs, and we might be able to access the logs using that approach. So these are the different scenarios in which the existing solutions, they don't suffice or they're not really helping our needs. And if we also go back and look at some of the best practices, like usually in cloud native applications, we talk about 12-factor apps, or it started with Heroku proposing 12-factor apps to build a portable apps, which is easy to migrate from one environment to another. One of the main tenets of those 12 factors is a centralized logging. It treats logs as a continuous stream of events, and they recommend that you write it to a standard output instead of writing it to a file or storing it in a database. So if your workload moves from one to another or one infrastructure to another, it becomes easier, and then you aggregate those logs. So in that sense, what we are going to do is we will jump into our first demo today. I'll be using an application which is called as the Tech Talks, which I've been using for my demos for last 2.5 years or even longer. This consists of a RabbitMQ producer service, which takes a number of messages to be generated as a parameter, and it generates those many number of messages, pushes them onto a RabbitMQ. And then there is a consumer which automatically scales based on a configurable number of batch, and it will pick those messages and process them. So what we will be doing here is we will use a commonly used stack nowadays, which is Elasticsearch, FluentBit, and Kibana. So let's start with FluentBit, which is the F part of this short form. So FluentBit acts as a log collector and log aggregator. And this is installed on all the nodes. It will collect all the logs, which are going as a standard output or standard error for that matter. And it will write those logs onto optimized environment, which is for log storage, which is Elasticsearch. Elasticsearch has been there for quite a long time. So you might have used it for even not just the cloud native applications, regular applications as well. It's been in the market for quite long period of time. And then we use Kibana to visualize these logs. And we can build dashboards, and various kinds of different widgets are available in Kibana to visualize those logs which are stored in Elasticsearch. So let's go and see this in action. I'll switch to the demo mode. So the first thing we will do is go and generate the workload for our producer. But before I do that, let me show you the current state of the RabbitMQ cluster or the number of messages. If you look at this screen, there are no messages in the queue right now. And there is one queue which is running on one node. There are no publishers or consumers in the current state. So I will go and use Postman to publish some messages onto this queue. So let's say 2,500 messages. If we get a status 200 OK here, that means these messages would be populated in the RabbitMQ. So I'm just stepping ahead a little bit here. What I'm showing you is actually Grafana. So that's the second part, but we will use this in combination with the Elasticsearch for timing. So so we should see those messages showing up here. So you can see 2.5K messages, and then these consumers will also be scaling in now. So the consumers is also scaled based on a framework called as Radar, Kubernetes-based event-driven auto scaling. That does a polling every 1 minute. So within a minute, we should see the consumers coming up and start processing these messages. Quickly go back to the terminal and see everything is up and running. So I'm using Windows Terminal here, which is again one of my favorite terminals. If you have not used it, I recommend that you start using it. So we do have Grafana running. We have Kibana is also running. Okay, let's go to Octant and see what's happening. So Octant is like the visualizer, which again I find very useful when we want to visualize the state of the Kubernetes cluster. And in the workloads, we can see how many pods are running. I think it came up. Yeah. So we can see that there are 600 messages now, which have not been acknowledged, and there are already 8 consumers. So the consumers have been auto scaled, and we will see that these consumers, they start processing the messages. Now, my producer and consumer both are writing logs to the standard output. How do we see those logs? In a normal scenario, let's assume that we don't have Elasticsearch or FluentBit installed. One of the ways to do that is use something like Octant, where you have access to the workloads which are running on the cluster. And then let's say you go into one of these pods which is running. So I have a RabbitMQ consumer here. And if I want to see the logs, there is an easy way to see these logs using Octant. So we can go to the logs section and we can see the log stream as and when the log is written from that particular pod, it will show here. The other option is if you have access to the Kubernetes cluster using kubectl, then you can use the kubectl logs. So I will use the aliases here to reduce the amount of typing, but I know there is a pod named db deployment 0, and if I want to see the logs of this, I can say kubectl logs and then the name of the pod, and it will show me again the logs for that particular pod. So these are different ways in which we can access the logs of workloads running on Kubernetes, but it's not very user friendly. First thing, you need to understand those commands. You need supported by kubectl, or you need to have an additional tool like Octant. So as we said earlier, we can deploy Elasticsearch and the FluentBit and Kibana and visualize the logs. So I've done the deployment ahead of time to save some of the time for us. And this is how the Kibana UI looks like. It gives us an option to create an index based on the data that is coming from FluentBit, the aggregated logs data. And then we can use this discover feature here to see how many logs are there. And it will give us like a different time frame, which we can see. We can drill down to different time frames like today, this week, 15 minutes, 30 minutes. So I'm seeing the logs for last 15 minutes, and this is refreshing every 10 seconds. So we can see that since we generated that workload, 720, that's or 730, close to 730. There is this log entries which are being written, and we can see what is the logs which are written here. So the complete JSON string, which comes as the log, along with a lot of metadata, will be shown below. Now, this is full if there is a support engineer who wants to look at how the process is running, if everything is going as per expectation, or this can be also exposed to, let's say, a business analyst or a business user, how Kubernetes works or what the underlying infrastructure is. They can be given access directly to this Elasticsearch, and they can do all kinds of quick searches here. As I said, Elasticsearch is optimized for search kind of scenarios or text-based searches. So we can also filter here quickly for some strings. So I know that in my consumer code, there is a string called as tech talks persisted successfully. So if you go back to the consumer, you will see it here that it says tech talks persisted successfully. So I know that when the tech talk is persisted, it is writing this. So I can search for that kind of strings here, and we will see that the number of hits within last 15 minutes, they should be refreshed to reflect how many entries in the logs contain this particular string. So you can see the results here. Let me just zoom in a little bit. So all those logs which contain that tech talks persisted successfully are now filtered. So it can be very easy, as you can see, to filter the logs, and then you can also filter based on different tags or different metadata, like what account is used, then what is the host from where this log came in. There could be some application specific labels. All this kind of information is populated when the log entry is published or when it is scraped by the FluentBit and pushed onto Elasticsearch. So this metadata can be used to build different kinds of dashboards and things like that. So how do we configure this on our cluster? So we saw how to generate logs and how to publish it onto Elasticsearch. What is required on the setup part? So I have a small script here which does this Elasticsearch setup or EFK setup. I'm using Helm, which is a package manager for deploying applications on Kubernetes. And Helm has this concept of something called as chart. A chart is like a package with all the Kubernetes objects that are required to deploy an application. So I'm using a repository called Elastic, and in that there is Elasticsearch as one of the projects. So I install this Elasticsearch, and I'm installing specifically 7.13 version of that particular chart. Once the Elasticsearch is installed, I go and install the FluentBit, and I need some additional configuration for the FluentBit. So I use a concept of a values file here to override the default. In case of Elasticsearch, I'm not overriding any default. I'm using whatever are the default values for that chart. But for FluentBit, I convert it into a daemon set. So daemon set in Kubernetes is like a daemon running on each and every node. So let's say my cluster gets auto-scaled. I don't have to do anything extra. By deploying this as a daemon set, the Kubernetes API will automatically take care of deploying the FluentBit agent or whatever is required on the new node. So that is why I create this as a daemon set. And then I install Kibana, and then I set or I override the values to say what is the host for the Elasticsearch master and what is the port. So these two are getting set by the first Helm chart that we deployed for Elasticsearch, and we are just using those properties here. So with this, my Kubernetes cluster has all the objects which are required for running EFK stack. And on the application side, I don't have to make any change. As long as my application is writing logs to the standard output, which is like console.log or console.write kind of thing, the Fluent bit will be able to pick those logs. It will aggregate them and it will be able to push them to Elasticsearch, and we'll be able to visualize them using Kibana. So that was the first part about logs. Now let's move on to the second part, which is monitoring and alerting. So same way, we try to understand why do we need monitoring and alerting, and same concepts for container-based workloads. Application-specific things we need to monitor are monitor the resource usage. So in Kubernetes, we have this concept of the request and limits, and if the developers or the application programmers, they don't know how to use this feature, they might request for resources which are much higher than what we need. If let's say they are coming from traditional background, and in a typical microservice environment, we should try to reduce, because microservices are very lightweight in nature. The amount of resources that they use are also less as compared to a monolithic application. But if developers, they don't provide proper resource constraints, then the cluster might be using or providing more resources than what is required for running those individual microservices. Also for the scaling needs, so I'll show you later in the cluster that I have a 2-node cluster and I'm trying to scale beyond the capacity of the cluster. So let's see if it is still there. If the workload is running, I might be able to show it to you here itself. And in this case, what is happening is the KEDA autoscaler is requesting for 30 pods to be scheduled, but my cluster doesn't have enough resources. So you see here at the bottom that there are 43 requested by the API scheduler to be scheduled. There are very few, I think only 8 are running for the consumer, and there are others which are in pending state. This is because my cluster doesn't have enough resources. I created, let's say purposely, or when I created the cluster, I created cluster with 2 nodes, and this just happened to be like a good side effect of that, which I could show you during the demo. The third thing is we need to monitor the anomalies. So we can specify the what should be provided at, let's say, scheduling time, and how much resources can be used by a pod when it is executing. But it might so happen that for some reason the workload is or your application crashes and it doesn't get rescheduled. So these kind of things we need to definitely monitor from an application point of view. From the Kubernetes point of view or underlying infrastructure point of view, we need to monitor the usage of CPU and RAM, how those are being utilized, how much CPU RAM is available across the cluster, how much of that is being used by different workloads. We also need to see what is the API health, because there are many APIs which Kubernetes needs internally to work. And if something goes wrong with those APIs, we might have a cluster which is not performing as per the expectation. And obviously auto scaling. So the concept or the idea which comes to my mind in terms of auto scaling is sometimes there are default settings which are provided by a cloud provider. Say, for example, you have the limit on the number of pods that can be scheduled on a particular node. And you might have a very high capacity node. Let's say 32 GB RAM is there or 56 GB RAM is available. But your default setting says that only 30 pods can be scheduled on that node. In this case, you will be paying more to the cloud provider because that node would be underutilized. And if you have enabled, let's say, auto scaling, moment 30 pods are scheduled, Kubernetes will go and automatically add new nodes because it needs, let's say, additional resources. So you will be underutilizing your cluster. So these kind of things needs to be monitored closely. If we are talking about PaaS and serverless kind of services, again, based on the kind of service that you use, there might be limits on the resources based on, let's say, the SKU. If we take database as an example, Azure SQL, there might be limits on the number of CPU RAM that can be allocated for, let's say, basic or standard kind of tier as compared to a premium tier. So you might start with a lower number of resources, and then if resource starvation happens, you can upgrade the tier. So to look for those kind of opportunities, you need to monitor even for PaaS and serverless services, and to identify any bottleneck. So it again goes back to this resource. So in case of some of these services, there are limits up to which they can provide the response times and things like that. So if those kind of contentions happen or some bottlenecks happen, we should be able to identify them quickly so that our application doesn't get impacted. So for that purpose, we'll be using Prometheus. And I already did a session in August, which was like a deep dive for how we can use Prometheus and Grafana. So I will not go too much into details. I recommend that you can go back to our channel and you can see the video of that particular session. So it's available, I think, under the August session that we did last year. So it's not that old. So the things that I showed there, they are still quite relevant. So you can find that session here. This is the one I'm talking about, monitoring the Kubernetes cluster using Prometheus and Grafana. So what I want to show you during this session is instead of configuring how, because some of you might be attending this session, how we can use this. So when it comes to Prometheus, Prometheus uses a time series database to store various metrics. And there are 4 major components for Prometheus setup. There is a Prometheus server, which uses this time series database. It uses a pull mechanism to pull the metrics. So the applications or whoever wants to publish metrics to Prometheus, they have to provide an endpoint where Prometheus can subscribe. And from there, it can pull the metrics on periodic basis. There is an alert manager, which can be configured to send alerts or notifications via different integrations. It integrates with PagerDuty. We can send email. We can use things like Slack channel or Microsoft Teams. There are various ways in which you can use this alert manager to notify in case something goes wrong. And then there is Prometheus Web UI, which is used to query the data stored in Prometheus database using a proprietary query language called as PromQL. But what we will be using is Grafana to visualize the data stored in Prometheus. So Grafana is a generic tool which is sort of specialized in visualizing data. It has various connectors, and Prometheus is just one of them. So we will use Prometheus as the data source for Grafana, and we already saw that just before. So this is a dashboard which is showing different metrics related to RabbitMQ. This I got from one of the online published dashboard. I didn't create any of this. I will show you how to pull a new dashboard into your own instance of Grafana. But you can see that it provides various kinds of widget. So we can have these different metrics provided. There could be tables, there could be graphs, charts, various kinds of widgets, and the look and feel is quite intuitive. You can go and modify each one of these as per your needs. So if you go to edit, it will give you the option to change the data source from where this connections data is coming. You can change the colors here. If you want a different representation from this line graph or line chart to something else, you can do all that. It's up to your expertise in terms of visualizing the data and your creativity that you can explore this. So for this demo, what I will do is I will use a Spring Boot based application. So let's go back to the slide and have a quick look at the setup that we'll be using for the demo. This is a demo application which is called as Conference Demo. It has a list of sessions, it has a list of speakers and their joints. And then we use Prometheus to collect the metrics from our service. So the API provides ways for us to query the different sessions and speakers and other things. So we will use that, and all this is running inside our Docker container. So we have the API as well as it is using SQL Server 2019 to run the database. And Prometheus will also collect some of the infrastructure related metrics or the cluster level metric. So I will show you first how to look at the cluster level metrics. You can go back to browse, and when I install the component related to Prometheus, I'm using something called as the Prometheus stack, which is a sort of combination of different charts using Helm again. I'm deploying this for Kubernetes, and it provides us these default dashboards. So once the installation is successful, I will get all these various dashboards related to the Kubernetes API server. I can look at compute resources. I can look at namespaces by pods, namespaces by workloads. So let's look at namespaces by pods, for example. So this is giving me what is the utilization, like CPU utilization from the request and the limits, the different pods which are running. And I can also change here, like whether it's for default or Prometheus, the data source. In our case, we only have Prometheus configured. And then I can also select different namespaces. Same way, let me also show you one more. So, part or the node. How does it behave on the node? So here we have two nodes, and we can again see how the different aspects of the resources are utilized on those nodes. So all this is again pre-created for me, and I can use it as is as part of that cube stack, Prometheus cube stack. So it installs all those four components that I mentioned, and it installs this dashboards. Now coming back to the Spring Boot application, I again pull down another dashboard which is created by Istio, which is specifically for Java Spring Boot application. Make sure that all this port forwards, they are running fine. Looks like there was some problem. Let's send it again. So, okay. Refresh the dashboards, and then we will go back to the Spring Boot dashboard. So in this dashboard, we have application specific metrics which are related to a Spring Boot application or a Java application. So we have metrics related to input output. We have how much heap is used in terms of memory. Then there is the JVM memory, and we have average HTTP request time as well. How much is the response time when a request hits the container or the server? So we have the average and the max, and right now there are no workloads or there are no requests running for this application. So that's why it's sort of very flat. So what I want to do is I want to generate the workload here. So let's go and query that particular API, and let me just clear this. Okay, so I want to run in a loop and request for the speakers 3000 times. So let's trigger this request. And now it is requesting for speakers. Let's do the same thing for the sessions, and we will request 1,500 times in a loop for that. Some problem with these sessions, but speakers is running. Okay, let's go back. Okay, no problem. Looks like maybe IP is wrong or something is wrong. No issues. At least speakers is going on. So we should see as a result of this workload, there should be change in these values. So you can see here that the IO, it has gone up because those requests are being serviced, and the average time, response time, is also changed. So we can get this kind of metrics in real time. As and when the application sees a change in the pattern, we can easily visualize those kind of things using these different application specific metrics. And this is again configurable in terms of how frequently the data is collected by Prometheus. So in this case, I think the default is 15 seconds or 20 seconds, and that is what we are using to refresh the different metrics values. So I'll not go into the details of this because I already covered this in the other session, which I showed you in the YouTube channel. If you want to understand how to configure all this, I recommend that go back and watch that. One thing I want to show is how to add a new dashboard. So we looked at Spring Boot application. There is also a .NET application which I have and which is also publishing some metrics. So I want to pull a new dashboard, which is again publicly available for a .NET kind of application. So for that, I need the URL where that dashboard is published. So let's look at this one. They are published on grafana.com under the dashboard section, and they have a unique ID which is used to identify them. So let me go to Grafana and let's add this for a .NET application. So under browse, I will create a new folder here, and let's say .NET, and we will put our dashboard under this one. So the folder has been created. Let's go to manage dashboard, and we use the import facility to import the dashboard. So we put that URL here. That is one approach, or we can take the JSON. It's basically a template or a JSON definition containing all those widgets and how they should be represented. So you can directly also put the JSON template if that is available. Then we say load, should be the one from Grafana. Then we put that under .NET, and we need to select what is the source. So Prometheus is automatically configured by, again, that cube stack as the data source. So I use that as my source. And now you can see the matrix which are coming from a .NET application. So this is that Tech Talks auto scaling one, which I showed earlier. So these metrics are related to that. So you can see that it's quite easy to use the publicly available dashboards, and then you can customize them as per your needs. Now let's move on to the next section, which is exception handling or error aggregation. So why do we need exception handling? There are so many applications and which are like legacy, and people are migrating them to these different platforms. Even if we do, let's say, a lot of testing, automated testing, functional testing, there could be scenarios where something goes wrong in the runtime environment, and we need to see what went wrong. In today's scenario, I would say that it is quite difficult to test all the permutations and combinations, especially if you are publishing something on web, for example. There are different types of operating system, different mobile devices, different form factors, so many things. It could be operating system is iOS, or it is Android, or you could be on Windows, Mac. The situation can happen on a different kind of browser, for example, and it's not possible for application team or testing team to test each and every scenario. So in that case, we can use something called as Sentry in this case, which allows us to use the APIs which they provide for different programming languages and different platforms to handle the errors or exceptions. So in this case, I'm going to show you not the application which is deployed on Kubernetes cluster, but outside Kubernetes cluster, and how we can integrate with SaaS-based Sentry platform. This has a certain number of free kind of units which I can use for testing purpose, and that is what I'm using for this demo. So here we can see the architecture of Sentry, how it looks like. It uses various components like Kafka, Zookeeper, Redis, a Postgres database. But from our application point of view or development point of view, all that we need is to create something called as a data source name in Sentry, which identifies our application, and it gives us the APIs for different programming languages. That API to integrate our application with this. So what I'll do is I will again use this same Spring Boot application, the conference demo, and we will see how to integrate with this. Before we move on to that, I would need a small help from the attendees. And Asif, if you can help me post that particular link which I sent you.
Sure.
Yeah. If you have a mobile device with you, you can just scan this QR code, or you can also put that link, http 20.44.232.28.8080 API v1 crash boom. So what I've done here is to simulate a crash or a failure exception scenario. I've created an endpoint which purposely throws an exception. So this is that simulated kind of scenario. And while you guys are doing that, let me go and just generate again some exceptions programmatically. Back to the Windows terminal and again run a small script which will call this crash endpoint, let's say 10 times. So I'm hitting that same endpoint, what is mentioned in the QR code. This is the wrong one. I need one. Okay, so it went and it requested 10 times. I hope some of you were able to either scan the QR code, or you were able to use the link which Asif shared. So this is the Sentry UI, which gives us access to the telemetry which Sentry collects. So I have that Spring Boot conference app configured to collect the metrics, and we can see that there were 58 events or exceptions generated recently, and the latest one was 30 seconds ago. All these are categorized, or there is only one exception right now, which is the runtime exception. That is why it is showing everything tagged to runtime exception. But if I go into the details of this, what we will see is the last request, it came from a curl. So that's probably my curl script which is requesting. The user is unknown. It collects the version of curl from where it was called. It had this environment concept. So I didn't set anything, so it's treating everything as the production. Then it also collects from which server this particular exception occurred. And it shows a trace. How did this happen? So we can see that the breadcrumbs, it started with a HTTP request, and that HTTP request was the one which sent the exception. This is showing application specific only view, which is app only here. If we want full view, which is like the Java stack trace, we can use that view as well to understand the underlying methods which were called as part of this call. And then there is also a raw view, which also gives more details into the exception stack or the stack trace. So in this case, all that I had to do was to use the API for Java or Spring Boot to integrate Sentry with my application, and it was able to collect all this information. Let's go back and look at some of the other values. So if I go older, for example, not the latest one, and we should be able to see some other requests as well. Or let me just go to the summarized events page where it will show us categories by from where the request came, like whether it came from a mobile browser. So you can see here that it's able to capture that it's running a Safari browser on mobile iOS 15 device. So probably one of you would have used your iPhone to scan that QR code or hit that URL. There is Edge also. So it's able to identify that this is coming from Windows 10 and the browser is Edge. These are all the curl requests which are coming. Mac OS also in the past, there has been request which originated from Mac OS. So all this kind of telemetry, which is typically related to the end user environment, is automatically available as part of this Sentry. So there are so many other features. I'm just showing you the tip of the iceberg here. Let me show you how to do this or how to enable this from an application point of view or application developer point of view. The first thing that we need to do in Java application is there is this dependency management file, which is called as the POM file. There we need to add a dependency for Sentry. And this is typically the format which is used in Java. We give the group ID, the artifact ID, and the version. So there is a Sentry Spring Boot starter dependency available, which we add. And then in the application configuration properties file, which is also another common practice for Java applications, we need to provide a DSN. So this we create in the website or the portal, which gives us a unique URL for our project. So when I configure or when I create a new project, it will give us this DSN. And I've created this DSN as a configuration value or config map in the Kubernetes. That is why I'm using this syntax here. So in my environment, it's available as a config map or environment value. And then if you remember, I showed you that app only view. So I can configure this to say, Sentry, please, when you show the logs or when you collate this information, you try to look at this particular namespace or this particular package, which is specific to my application. So it will aggregate or it will combine those telemetry data and show us for this particular package. And then I can also define a sampling rate. Here I'm giving all 100% exceptions which are caught or which are used by Sentry, but I can also give a different percentage here if I don't want each and every exception to be monitored or to be captured by Sentry. So with these two changes, my Spring Boot application is able to capture all that telemetry data, the end user data, and all that information that we saw in the browser. If we are using it for .NET, then the process is slightly, I would say, involved. The initial step is same, where in our dependencies or in our packages, we need to add a package. So that is my in the producer, for example, we have the CS project file. We add this package reference for Sentry.ASP.NET Core. And then in the startup, we need to add a call to use this Sentry tracing. So it does involve a code change for a .NET application to say that you have to use tracing which is provided by Sentry. Middleware of ASP.NET Core or ASP.NET application to be able to capture this. And once this is done, then we can use it as part of our application. So let's go back to these slides. Thanks to all those who helped to really scan this and give us a real-time information. So what we saw here was end-to-end observability thing in the 3 different demos that I showed. We started with log aggregation using the EFK stack, where both the RabbitMQ based information for a .NET Core application as well as the Spring Boot application was available. Then we used Prometheus and Grafana for collecting the metrics, and we looked at 3 different types of metrics there. First is the infrastructure level or Kubernetes level metrics, where we looked at that node and the pod and the namespace level metrics. Then we looked at the application metrics, the Spring Boot as well as .NET Core application, and also the middleware kind of matrix, which was for the RabbitMQ. So it is quite easy, I would say, to integrate this in your applications if you know how to do that. And then we also looked at Sentry, which is for the exception aggregation or handling, collecting telemetry regarding the exceptions. And we also looked at how to integrate it for a SaaS platform, not something that was running within our Kubernetes cluster, which was the case for the AFK and Prometheus and Grafana. So there are some challenges if we see what we did so far. If this is so easy, then everybody would have been doing it. But it's not so easy in the real life applications. And these are some of the challenges which are mainly faced when we start to onboard applications using these different tools, technologies available for observability. First thing is there are too many telemetry agents. If you look at the different technology stacks or different cloud providers as well, we have, there is, let's say, VMware, there is the on-premise things, there is Windows, there is Linux, all different flavors, and they have different ways of generating data, which might be in completely different formats. So for each of this, you might need a different kind of telemetry agent. The other example I can think of is, again, polyglot programming, where you have, let's say, front-end applications built using JavaScript or Node, for example, or mobile applications. You have websites or web servers, you have database engines, and different kinds of services. So it's not so easy to have, let's say, just one kind of telemetry agent which can service all these different use cases. Then the next one is instrumentation. Again, if you look at these different kinds of technologies and technology stacks, the way we instrument front-end JavaScript-based code is different compared to the way we instrument, let's say, a relational database as compared to a NoSQL database, and then the application or the services code. All these have different ways of instrumenting. So that's another challenge. Specifically with regards to cloud native application, these are all dynamic and When we talk about microservices, these are small units. So people are using things like serverless, which runs only on demand. So this adds to the complexity. Then comes the retention period. So not every type of matrix is required to be stored or retained for same amount of time. So it does take quite a bit of, I would say, mathematics or things to identify the right type of matrix and how much amount of time it should be retained. And this obviously goes based on the usage. The minimizing of vendor lock-in or feature lock-in is another concern or another challenge. So as I said, each cloud provider or each type of vendor, they might have their own ways of providing telemetry data or own ways of collecting this data and providing access to that data. And even within the same provider or vendor, they might have difference in terms of, let's say, they have a SaaS product and they have a product which is installed in our own environment. So the features might be different. So that is other challenge. Build versus buy is obviously standard across software industry, I would say, for most kind of things, whether we should build everything our own or we should buy stuff which is available. And then transitioning from monitoring to observability. In the resources, I've shared a link from Dynatrace, which talks about what is the difference between monitoring and observability. Monitoring is basically you're looking at just one component or one aspect of the system. And it is looking for sort of known faults or known errors. Say, for example, disk as an use case. You are monitoring the disk usage and you would alert if the remaining disk is less than 25% or things like that. Or it could be at the database level where you have concurrent connections and you create an alert if a certain number of connections are currently using the database. Whereas observability is more about using different kinds of monitoring or different kinds of components to look at things which might not be known in advance, but you want to make your system reliable, and you use combination of these different individual components to come up with a better monitoring and observable solution. Once we start using all these different components, then collating that information in one single pane of glass is again a challenge, because all these different tools, they might have different formats, different representations in the way which they store data. And if you have to make sense out of it, it could be quite a challenge first to understand that particular tool and then to combine those data into, let's say, one single dashboard. And then correlation of signal. So again, this goes back to microservices, where if you're using something like a distributed tracing, for example, using Jaeger or some other tool, how do you correlate? So if your request goes, let's say, from your front end, it goes to a API manager. From the API manager, it gets redirected to a particular service. From that service, it goes to database. How do you correlate these different components? These are some of the challenges which are obvious when it comes to having a good observable solution. So I tend to use this analogy of using right tool for the right purpose. And I was recently reading this book by architect called Gregor Hopp. It's called The Architect Elevator. And there is also another book, The Cloud Strategy, where he gives analogies to explain concepts. So I will use the analogy of transport or different modes of transport. So we have the guy on bicycle, there is the guy riding motorcycle, we have a car, there is bus, train, truck, cruise, and plane. We might have used more than one of these at different points of time in our life, and depending on the need. So let's say we are traveling just within the city, we might use a bike or a scooter or a motorbike for that example, for that matter. Or it could be if you're traveling as a family, you might be using a car. If you're traveling in a group, you might be using a bus or train. But if you're crossing countries or continents, you obviously won't be using a scooter or car, or use boat or a plane most likely. So we need to find the right tool for the right purpose, and that is the tricky part. But why I'm saying this is whatever tools I showed you or whatever projects I showed you, they have overlapping capabilities. So dashboards can be built, for example, in Kibana. Alerting can be done via Sentry. Alerting can be done via Prometheus or Grafana as well. Is it the right tool? That's the sort of question we should be asking. Is Prometheus and Grafana built for alerting, or is it built for something else? Just because a tool has a capability, we shouldn't be using it. We should evaluate, is it the primary purpose why that tool was created, and is it the best tool fit for that purpose? So I hope this analogy helps you to understand better. So that brings me to the end of this session. And in summary, if there was any takeaway I would like you guys to take with you at the end of the session, it is that, as I explained in the previous slide, use the best of class or best of breed solution for a given use case. Identify what use case you are trying to address and find the best tool for that. Rely on open standards like open telemetry. Don't go with solutions which are vendor specific or which ties you to a particular vendor. Nowadays, it's quite common to have multi-cloud or hybrid kind of scenarios. And if you go with one particular type of vendor or you tie in yourself to one cloud provider, it becomes difficult when you want to port your systems or application onto other platforms or other clouds. So build these kind of things which are portable. Use things which can be easily migrated or easily integrated from one kind of environment onto another. And just highlighted what did we see in the 3 demos: log aggregation, monitoring, and the exception aggregation. So I hope you found this useful. Based on whatever I've shown you so far, here are some of my recommendations. So we discussed about the challenges, and some of the tools which are currently available to address those challenges are listed here. So for example, too many agents, we can use, there is something called as open telemetry. It's again sort of standard for collecting telemetry from different systems, and they have defined set of interfaces, for example. So choose solutions which are using open telemetry. Instrumentation or vendor lock-in. Again, open telemetry and open metrics are recommended things to do here. When it comes to cloud native applications like logs, metrics, and traces, we can use things like FluentBit or FluentD. OpenSearch. Loki is becoming quite popular project, which is similar to the EFK stack in terms of logging infrastructure. It has better, or they claim to have better capabilities in terms of metadata management for logs and things like that. And then we already looked at Prometheus. There are other projects like Cortex, Thanos, and when it comes to the telemetry part, open telemetry is like a standard or a project, and then Jaeger and Grafana are some of the implementations of that. And for single pane of glass, we could use Grafana to collate information from multiple sources. Since it supports more than one data source, we can use it as one of the tools for collating all the information. So for your reference, I've given the links to these major projects and what are their websites. I've also given a link, as I said earlier, for explanation on what is the difference between monitoring and observability. I also referred to this guy called Hussein Dalai, who has a series of small posts or YouTube videos how to integrate Prometheus and Grafana for monitoring on Kubernetes. That is how I started learning, looking at some of his videos. And if you're looking for the source code, it's all on GitHub. And also the slides of this presentation, they're already published on SlideShare and SpeakerDeck. So in case you joined in late, my name is Nilesh Gule. The combination of my first name and last name is quite unique, and you will find me with that almost on all the social media, except for my blog, which is Hands-on Architect. And I also have a YouTube channel. In case you're interested in this kind of information, you can subscribe to that. So thank you. Thanks a lot for attending this session. I'm happy to take any questions if there are.
Thank you, Nilesh. Thank you very much for your wonderful session. And we have one question here. If we have any existing app running on Kubernetes with zero monitoring, how do we propose we should get monitoring tools inside the cluster production app? Are the monitoring tools installed on the same cluster in production?
It depends on how you want to do it. These can be, it depends on the tools as well. Say Elastic, for example, it runs, or the way I configured Elastic or Fluent Bit here is to run as a daemon. So you will have to install on the same cluster a Fluent Bit daemon to collect the logs. The storage part can be in a different cluster. So you can separate the monitoring part or observability part to a dedicated cluster. It's possible. Same thing for Prometheus, because Prometheus scrapes the metrics. It doesn't, nobody pushes the metrics to Prometheus. As long as Prometheus is able to connect to your metrics endpoint, it would be able to collect the metrics from either the same cluster or different cluster. I hope that answers the question.
Yeah, Prasanna, if you have any further question or if the answer is okay for you, you can unmute and can ask directly to Nilesh. Yeah, maybe I will help you to unmute. Yeah, I think, thank you, he said. So, hey guys, if you have any further questions, so you can ask. Nilesh, I have one question here. Means which type of production workload means we need to choose open source tools like Grafana or means Prometheus and native tools compared to the Kubernetes also have Kubernetes dashboard for logging and alerting all those. So what's the best way in your experience? Means like which tools is better in which scenario?
As I said, in that challenges and the options, right? It would depend on what is your current landscape. Are you planning for, let's say, migrating from on-premise to cloud, everything from your workloads? Are you planning only one cloud, or you want to go multi-cloud, or you want to go hybrid cloud? If you're planning just for one cloud and you don't have intentions of spreading across, let's say, multiple clouds, then you can rely on the cloud provided tools. Every cloud provider has their own monitoring tools and they support different SDKs as well, right? But then you are tied up. You are sort of like a vendor locked in with that cloud provider. In many cases, what we have seen is nobody is in a situation to straight away go to a cloud unless it's a complete new application or let's say a greenfield application. Many of the applications which are migrating to cloud, they have a mix of hybrid setup, right? So in that case, you need something which can work across your on-premise as well as the cloud provider. So that is where you can choose for an open source solution. And if you are thinking of multi-cloud scenario, then obviously I would recommend that you choose something which works across all the clouds, not just the public cloud. Even if you have, let's say, your own virtual cloud or internal cloud, you need to find a tool which works across all these different providers. Otherwise, you will need a different solution for, let's say, one cloud. And when you try to look for end-to-end observability, it will become a problem for you. You will have a lot of what is called as a toil in your monitoring team or your SRE team to identify where the problem came. And you'll be spending a lot of time in where it might not be worth spending.
Okay. Yeah. Thank you.
Answer your question?
Yeah, it's perfect. I think. Thank you very much for your session and wonderful session. And I have shared all your GitHub links and blog links and your YouTube channel. So if you guys are interested, you can subscribe to Nilesh channel. And there is also a blog and GitHub link I have posted. So yeah, I think you can get all the latest details on blog and GitHub. And thank you very much for joining today. And we have upcoming sessions we'll announce soon, maybe within 1 or 2 days. So you can just be in tune in with meetup.com or our Facebook group. And thank you very much
Thank you,
for.
Nilesh. Thank you very much for this session. Cheers.
Thank you.